Hi folks, I will not be introducing myself because beautiful people from GDG already did it. Okay, so today we're gonna do Cloud Spanner, kind of Cloud Spanner 101, 102 session. Before we start, I'd like to ask for a quick raise of hands. So raise your hand if you are working with Google Cloud. Cool. Yeah, I know about you guys. Raise your hand if you know about Cloud Spanner or if you have worked with Cloud Spanner. Yay! Nice. Cool. So, what we'll do today is we'll do a quick overview and maybe... Just a second. Can I also get a screen here? Just so that I wouldn't have to do like this all the time. Okay, I'll be damned. Thanks. Okay, so we'll do kind of something similar to Spanner 101. So we'll discuss on what Spanner does, why it exists, how it does what it does, and when to use it, and when preferably not to. Also, if we'll have time at the end, it will be either demo or Q&A, or demo with the Q&A. So what is Cloud Spanner and why it exists? So the picture behind me is the typical web scale pane for someone who has started doing whatever development, whatever application they have started with the relational DB. So at some point you hit the limitation of one master which serves your rights. You start sharding, you start doing replicas, you start getting more and more infrastructure overhead on the database layer. So your write capacity is limited with what your master can survive, whether it's MySQL master, PostgreSQL master, even Microsoft SQL master. You can do horizontal sharding. If you do that, you get into additional layer of complexity of how to spread your tables across multiple actual hosts and how to serve the writes from it. You can do vertical sharding, but with vertical sharding you have to pick the criteria, whether it's a customer ID, city, country, whatever. And if your major market is in US, you can always hit the limitation of one particular shard, whether it will be US or the biggest city where you're serving. And also, obviously, don't forget about keeping your database highly available, making sure that you have a failover mechanism when your master will die and the application will be going down together with it. The good thing is that Google was the same back in 2015. Back in 2005. Back in 2005. So back then, actually, AdWords was powered by a very large footprint of MySQL deployments with sharding on customer ID. And AdWords, like we like to say, is that every dollar generated out of AdWords was done on the back of MySQL. And latest resharding effort that this infrastructure was actually overcoming coming through took years to complete. So that's when Google actually started working on something better for the goal like this, while still be able to keep it relational and keep it transactional. So why relational and transactional? The system, such as AdWords again, was dealing with money. So we needed to make sure that we could keep track of what was happening in the database, that transactions were consistent, that we wouldn't lose the data, we wouldn't get the downtime, and we could scale horizontally. Horizontally while still keeping the strong consistency. And that was actually the moment when the system called Spanner got introduced and got developed. The funny thing about Spanner is that there are multiple interpretations of why the name is actually going like Spanner. So first one that British folks like is this. So Spanner is how in UK many people call this beautiful tool. My personal preference, and I've actually seen people in Eastern Europe preferring it, is this one. Like, very lively and similar to the icon. Well, in reality, it's more about this. So the name Spanner comes from the notion of spanning multiple geographies. And the Spanner itself, which is run by Google right now and powering multiple systems such as Gmail, is working across the globe. So it's a global system which involves multiple regions. In terms of Cloud Spanner, I will talk in a minute like how it works right now in terms of availability zones and in terms of the regions as well. So that's database. Oh, you don't see it. Okay, that's good. So that's the database which, like some people also joke, beat the cap theorem and make sure that you can have multiple writes across multiple geographies. I don't talk and drink anymore. Okay, so what is Cloud Spanner? Cloud Spanner is the fully managed database as a service on top of Google Cloud. It provides you with a horizontal scale. It provides you with actual strong consistency while still keeping the relational semantics and keeping the transactions. It does automatic synchronous replication across multiple regions or across multiple availability zones. So in terms of the regions, right now the Cloud Spanner, which is offered in Google Cloud, does only replication across multiple availability zones in one region. Doing replication across multiple regions is technically there. It's just not yet released on the public service. So stay tuned. It will be there next year. The technology itself is battle tested with Google. So like for 5+ years, it was used by Gmail. It was used by AdWords. It was used by multiple other services. Also, there are obviously customers who have been running it in early access program for like a year and something already. But it's important to understand that Cloud Spanner offered on Google Cloud and Just Spanner, it's the same technology but different instances. So Just Spanner is internal to Google, Cloud Spanner is offered on Google Cloud to everyone. So yeah, now what's important and what Spanner has been evolving in is being compliant to certain open standards and being compliant to what enterprise is actually expecting. So right now it supports ANSI SQL 2011, I guess with some extensions. You can do it for querying, and I'll explain later for how to do it for writing. It does encryption, audit login. It also does identity access control. So if any of you have been trying Spanner with while it was still in beta program, I will show on demo right now. There is much more controls on how you can actually manage the database, which is running in Google Cloud. It has GDBC driver for read-only mode, unfortunately, yet only, and it has client libraries for reads, writes, and all sorts of mutations for many major development languages. Now, how does it compare? So Cloud Spanner, as you can see on the left, it checks out across multiple characteristics where traditional relational and non-relational are kind of on the fence. It does strong consistency, it does high availability without need of manual failover or having something like, you name it, Zookeeper, JProxy sitting on top of your MySQL cluster. And it does the automatic replication. When to use it, well, not when to use it, but typical kinds of workloads. Transactional, scale-out, global data plane, database consolidation. Database consolidation is actually funny because I tend to think about database consolidation more in lines of BigQuery, less about Spanner. But in reality, it's well, almost any workload where you want to stay relational, where you want to stay with transactions, but you want to scale horizontally and you want to not be limited by the capacity of a single master node. Yeah, we'll talk about Quizlet a bit later. So, how Spanner does what it does. So, key elements of the architecture. Instances, nodes, zones, regions, splits, and a bunch of other things. Doing one step ahead, so on the left you see the screenshot actually from Google's documentation. Anyone who will want to dig deeper into Spanner, I really recommend going into these sections of articles. So there are some white papers there based on the public white papers where Spanner was actually started, and there are some very nice guides on how the transactions work, on how true time works, and so on. So when you start using Spanner, obviously it's in the cloud. I will show it on the console later. The first term which you meet is the notion of instance. So instance is not a virtual machine de facto here. Instance is the logical unit of Spanner inside which you allocate serving capacity, so compute capacity, and storage capacity. When you create an instance, in fact, what happens right now in the cloud is that you get the replica of your compute nodes, and you get the replica of storage provisioned across three availability zones. So you don't have to configure replication, you only specify the amount of nodes that you want, and nodes I will show in a second. Also, in terms of the database and actual data that will be stored, it will be automatically replicated across 3 availability zones as well. And compute and storage are actually separated, so it's not like you create a bunch of VMs and serve both CPU and storage from the same pool. Now, the notion of node. when you create an instance or when you edit an instance in Cloud Spanner, you specify how many nodes you want to be in there. Nodes are not VMs, nodes are the units of capacity. So how much QPS your Spanner instance will be able to serve, how much storage, net storage obviously, it will be able to serve. So the official recommendation is that when you run your database in Cloud Spanner and when you put the application workload against it, is that you keep the utilization up to 75%, both in terms of the QPS that you generate and in terms of the storage that you serve. Right now it's quite easy to monitor it because we have support in the monitoring tool called Stackdriver for all Spanner related metrics. So as soon as you get into the threshold of 75% utilization, you can just scale up. So I will show it on the demo. You can just come into your Spanner regional instance and add some nodes. Obviously no downtime, so Spanner will take care of introducing an additional node and rebalancing the data without you having to take care of it. Next notion that we have to take care of is splits. So splits is actually my favorite part because in fact what it does is it explains you how Spanner will automatically share your data. So you'll never have to actually do the sharing on your own within Spanner. So for every top level table which has the primary key range, Spanner will identify certain subranges and it will split your data onto data splits. And it will make sure that every zone where your original instance is working has the copy of one particular, of this particular chunk of data, this particular split. And it will make sure that the leaders of every split, determined by Paxos, are distributed across multiple availability zones. So if you have deployed a Spanner cluster and you're running it with 3 nodes, both reads and writes will be distributed across all the nodes involved in this cluster. So the leader of the split can be changed over time because, again, you can change the amount of nodes that you're running. And the best part is that Spanner will actually reshuffle and reshard your data as it sees fit. So there is a solid amount of R&D done behind it to see what sort of load patterns your application will be exposing, what sort of capacity you might be adding or removing from Spanner. So if you add the node or if some particular key range becomes the hotspot, so that like you will be doing a lot of reads from it or a lot of writes into it, Spanner will automatically rebalance your splits and make sure that it takes the best use of the capacity that you have allocated to it. So no more manual sharding, no more manual resharding. It will be all taken care of on the back end by the technology itself. So yeah, as I mentioned earlier, that's the example. So these are the Spanner nodes which we have involved, and their replicas across multiple availability zones. The data is being split. By the primary key in your table, by primary based on the load patterns. And what's important actually is when people start using Spanner, they get surprised, and I think it's similar for Bigtable as well, that at the beginning the performance is kind of lower than you would expect. But as Spanner learns more on the read and write access of the data, the performance gets better. And then people start asking, okay, but how would teach Spanner to do it up front? Just design your schema right. Yeah, so for every split there is the notion of split leader. I think, no, it's not yet here. So for every split there is a notion of split leader. So the node which will be taken care of processing the writes for this split. And there are split slaves or split slaves that will be taken care of processing the reads. The split leader is determined by Paxos algorithm. Whenever again you add or remove nodes, or whenever the Spanner reshards the data, split leader might change. Nothing manually, you don't have to actually work on this manually. Now there is also the notion of true time or true time API. So one of the problems which Spanner had to solve in order to provide you with horizontal scale and transactional consistency is making sure that when operation is committed in through availability zone 1 or through region 1, there is a way to consistently propagate it into all involved Spanner nodes and keep transactions both serializable and linearizable. That's hard to say. So in order to solve that, Google introduced the notion of true time, and true time is based on true time is based on the technology with atomic clock and with GPS clock. And the goal is quite simple. Whenever spanner needs to commit a transaction, whenever spanner receives the request from the client to commit a transaction, and transaction might involve mutation in one row, the transaction might involve changes in multiple tables. There is a way for spanner to receive the timestamp from the true time API that will be guaranteed to be higher than any other timestamp that true time issued earlier. And because of that, spanner servers in different availability zones and different regions, they don't actually have to talk to each other and get the network latencies and get the NTP-induced latencies, because they always know what is the right time with the minimal mistake threshold. So this is provided by true time, and true time, as I said, is based on the fact that in every region and in every availability zone where spanner is running, there is a setup with GPS clocks, there is a setup with atomic clocks, which always knows what is more or less right time, and there is no network chatter to kind of synchronize on it. Now, let's take a look how the queries run in spanner. So one step ahead, jumping a little bit ahead, Spanner supports ANSI SQL 2011, but it does so only for read operations. So when you want to do the write operations, this has to happen through the client libraries and through the SDK that is provided to applications that are being developed on Spanner. So obviously Spanner is not a drop-in replacement for PostgreSQL or MySQL cluster. You will have to do actually some code to be able to start using it. The read transactions, they work on the SQL level as well. Well, not as well, they just work as the SQL. So first example, obviously, is the consistent read. So when the client is issuing the request, it goes through the Spanner API. It lands to the least loaded or the closest to the client slave replica. Slave replica will check with the leader on what is the state on this piece of data to provide consistent read. So it must have all the transactions issued against this piece of data committed, and it all goes through one particular shard. So there is no full database involved here. Leader might say that, yep, this particular piece of data which you're trying to read is not under any transactions happening right now, so you can just return it, return the response, and this will be the consistent one. Now, if we would want to do a read-write transactions, obviously no SQL anymore, so that's the code coming from the SDK functions. Client would have to issue the transaction where it would combine reads and writes. Leader would specify the logs for all. Leader would specify the logs for involved splits, and then leader would propagate the writes into slaves. Slaves would return the acknowledgement, leader would release the logs. Now, my favorite part is what is called, well, no, it's not yet that. So consistent reads for the situation when there are other transactions coming from, you would have to wait for the leader to say that, no, this particular slave still has the stale data in, so there will be some latency before client receives the response because there are other transactions being committed in parallel. Now, my favorite part is what is called time-bounded or stale read. So this is the read operation which kind of, in certain scenarios, helps you imitate eventual consistency. So when specifying read transaction into Spanner, and let's say you cannot tolerate certain latency which Spanner might introduce because of having to do all the previous transactions for the involved piece of data, you can specify that for this particular read, you're fine with eventual consistency or with having some stale data. Stale data in this case means that when you specify the transaction, you say how much, like how old or how stale data you are fine with returning for these particular transactions. So again, think of the NoSQL solution where when you read, you're expecting that some of the response might be stale, might be impacted by eventual consistency. Spanner can actually imitate this. A background addition or like performance perk here is that you can read the older data or older state of data even when it's not because of eventual consistency. You just want to read the previous version of data. So it works with certain parameters specified in the client which you execute. You can say that I want the data which is 15 seconds old or 30 seconds old or whatever. Slave would check that, yes, I have the data which is on this particular set of keys that is not older than 15 seconds, so we can return it, return the response. Okay. So now a little bit about how Spanner does the data layout. So the typical relational data layout is that you have the table A, you have the table B, and you have the foreign key. So in this case, Singer ID is the foreign key for us. What Spanner also introduces is so-called interleaved data layout. So in terms of the meaning for your queries, it's a very simple thing, a very similar thing. So the table which kind of becomes the slave, it has the piece of primary key of the master table as its primary key. But why Spanner does it? It does it in order to physically collocate the data. So that when you will be doing the reads, for example, when you will need to do the reads of albums recorded by Beatles, in all splits involved by in Spanner, in all replicas involved in Spanner, you will have this data physically collocated very closely on underlying tables, so that the reads will actually be faster. So in terms of SQL, in terms of data definition language, when you create the tables like that, it's very similar. It's just that the extension that you will have to introduce here is that you will interleave this table with the primary table called singers, and you will have the album ID being complemented at the end of the primary key coming from the singer ID. Now, one more thing about Spanner is that unlike many traditional relational database management systems, it allows you to do no downtime schema migrations. So it has its own tweaks or quirks or whatever. So if you will actually want to rely on it, it's not the same as if you would be running, for example, with data store and being able to change the schema on the fly always. But most of the operations like add the column, remove column that is not part of the primary key in Spanner can be done without downtime. So Spanner orchestrates propagating this across all the involved replicas of the nodes, and even while you will be changing the structure of the table, it will still be able to serve transactions for reads and writes, obviously depending on the parameters and depending on what fields you are actually asking for. But in general case, unless you're changing the primary key of the table and unless you're adding some kinds of indexes, Spanner does the changes of schema without having to introduce downtime. Obviously, if you run the production level, configuration with at least 3 nodes involved. Schema do's and don'ts. So the main anti-pattern, which kind of spans all the managed databases in Google Cloud, including Spanner, including Data Store, and including Bigtable, is not using monotonically decreasing primary keys. So when you're doing primary key, it has to have sense. It has to make sense in terms of the business logic that you're actually using, and it has to be not a timestamp. So simple idea is to do UUID version 4 or higher. Another idea is to introduce the primary key, which is based on something that is unique in your application. For example, username or an email, if you're enforcing it. And another do in this case is design your schema dependent on the primary workload. So in Google Cloud and in Spanner specifically, there are multiple options of doing database. So for Spanner, when you design the schema, the good idea is to design it specifically for what your application is trying to achieve. If later on you will want to run some non-real-time analytics or some batch analytics, it will be easier to export the data from Spanner into BigQuery and run it over there. So design the schema not to try to solve everything for everyone right away. Design the schema for the application which you are using right now. When to use Cloud Spanner and when not. So again, in Google Cloud there are multiple options of providing database for your application. The default one that many people are using is Cloud SQL. Cloud SQL is the way to migrate your existing PostgreSQL or MySQL database and not have to rewrite your code. But over there, you will have the same limitations of single master serving all your writes. You might have the limitation of having to do sharding. And the only thing that Cloud SQL will do kind of on top here is it will automate the management of backups, and it will automate the management of read replicas and failover for you. Cloud Spanner is not a drop-in replacement for MySQL, as I said. So if you are developing a new application or a new service, or if you are ready to adjust the code of the service that you have right now in order to get the benefits got by Cloud Spanner, that's an option. The rest of the services, so data store and bigtable, are less about, well, not about relational at all. It's about NoSQL. Cloud storage is for non-structured data, and BigQuery is for data warehouse and cold data. So analytics that you will be running later, not the real-time database that runs with your application. We also have something like that on the website. So it's already out of date because it talks about Firebase real-time DB, and realistically we're pointing people to Firestore now. If simplified, it goes like that. So if it's OLTP, not OLAP, not analytics, but actual transactions processing, if it's relational and structured, and if you want to keep it that way, so you don't want to migrate into NoSQL kind of structures, and if it's horizontal scale, so terabytes in terms of the size and high number of IOPS, that's a good candidate for Spanner, especially if you can actually tolerate and allow yourself to write the code against Spanner, because again, you'll have to use client libraries instead of what you might have already used earlier. So people always ask, like, how does Spanner compare in production? Who has tested it? And as I said earlier, while Spanner was in alpha and in closed beta, there were already plenty of customers who have been running on it using Google Cloud. And Quizlet actually has published a very nice, very big article, which I recommend to everyone who wants to keep reading and keep figuring out what Spanner is doing, about their experience with it. So the picture which I showed at the beginning with like one MySQL master, a bunch of replicas, shared it by whatever sign the Quizlet had there. It was from them, from this article. And the test that they did is they were putting, they have done the measurement of, they have done the capturing of the different query profiles that they were running against their production database with MySQL. And they have replicated the similar kind of load on MySQL deployment and on Spanner deployment. And Spanner deployment, they were even using different scale. So different amount of nodes to be able to serve different amount of QPS. And what they found is that at certain point of how loaded the MySQL deployment is, they get into rapidly growing latency up to a point when the physical capacity of the server is not available to, is not able to serve the load that they are putting on it. While in case of Spanner, well, in this graph we have median, but there is also there are also different ones when Spanner was also going up. But in case of Spanner, both read and write transactions were effectively distributed on all involved nodes. So as long as they were keeping the size of the Spanner cluster within the boundaries of QPS that this amount of nodes can serve, they were doing fine. Another interesting observation here is that while MySQL cluster is still capable to serve, it has much lower median latency, because Spanner introduces certain kind of a lower boundary of latency, which you will always have just because of the replication and having to do things synchronously. But as the cluster scales, as the load grows, Spanner remains consistent around this low level of around this minimal level of latency, while MySQL, depending on condition, can grow either very fast or rapidly, but still grow without being able to scale up, except of scaling up using the bigger virtual machine. Okay, now let's take a look at a bit of actual Spanner. Oh, it's interesting. I don't have space to see it. Just a second, I will switch into mirroring. Yay. I'll sit down. Okay, so that's Google Cloud Console, and here is Cloud Spanner. So what I'll do right now is I will actually walk you through some of the UI-based UX things around Spanner, which we usually do because some people have tried Spanner while it was still alpha, beta, whatever. And even Quizlet has published some complaints saying that, yeah, you can create an instance, but it's very hard to do something with it, even just to test some data without writing some code. So right now it's much more up to date and it's much easier to actually start trying and practicing Spanner. So let's say I want to create a new instance. I would specify the instance name. I can do the separate instance ID, and I need to select where I will place it right now. So right now Spanner runs, as you can see, in West 1, in Europe West 1, it's Belgium. In US Central 1, it's US, I actually don't remember which state, and 2 Asian locations. But as we go forward and as we go to multi-regional configurations, there will be more options available here. Now, in terms of the nodes, so here is the performance guidance, which I already was showing to you guys. So one node is expected to serve up to 10K QPS for reads and 2K QPS for writes, and up to 2 terabytes of net storage. So right away I can specify the minimal amount is obviously 1, but in this case I lose part of the redundancy, load balancing characteristics. The minimal amount for production that is recommended is 3. At the bottom I get the estimation of the costs. I will not be creating it because I have the instance ready to take a look further. So here I have what is called test instance, and when I get to an actual working instance, I get into monitoring and I get actually into being able to take a look at my databases and do some things. So when I go to monitoring here, I have the graph showing me the node count. So I was playing around actually with this cluster earlier today. I was adding and removing nodes. So again, no downtime. You can do it at any point. CPU utilization. So I didn't manage to load my poor cluster that much. But back to 75% utilization guidance. As you get to a point when you start hitting the red line, you just go ahead, edit instance, and add more nodes if you want them. And the operations login here as well. Throughput and total storage. Now, also when so these monitoring graphs, they are actually provided by a service called Stackdriver, which is included in Google Cloud, and where you can specify alerts. So for example, if your Spanner cluster gets loaded up over 75%, you can get a SMS message or something like that, that you should go ahead and add more nodes. Now back into overview. Here I have the database, and this is the database which I created using some of the sample code in Python, which you can also use from the Google Cloud documentation. I can browse through the tables. I can see the schema here. I can see the indexes, which I don't have, and I can take a look at the actual data. So data is quite visual. I can do filtering if I want to, and I can do inserts here. So if you are starting development with Spanner, it's not like it was like 6 months ago when right away you would have to you would have to kind of surround yourself with a bunch of CLI clients and a bunch of sample libraries, and even to generate the test data you would have to write code. So right now it's quite easy, it's quite straightforward. Also with the UI here, I can run standard SQL queries against the schema involved, and I can see the explanation. So if I don't have any historical queries here, so the same as BigQuery works, Spanner provides you with the explanation on how it executes the queries that you publish into it. So if you want to do some, if you will need to do some schema optimization, or if you will need to see why my query is running that long, there is reference documentation and there is UI here to help you out with it. So monitoring is here, UI-based management of the databases here, alerts to scale up and scale down is also here. So Spanner right now is quite easy to manage and quite easy to start actually adopting. Now, if you will want to actually try out writing data in Spanner, I recommend going into Google Cloud and going into tutorials, whatever language you prefer. And here there is a very nice rundown on basic setup of Spanner, and then the examples of the code which you will use. So for example, here they create a batch object to do the inserts into table. Again, as you remember, there is no way to insert with SQL right now. With SQL, you can only read. With the SDKs and with the clients, you can read and write. Okay, so no, that's a speaker notes. That's not what I wanted. There it is. Okay, so a couple of ending notes. So Spanner provides the relational database with automated sharding, load distribution for reads and writes, and data replication across multiple locations. Availability zones right now, later on it will be across multiple regions. It's a no drop-in replacement for MySQL or PostgreSQL, so you will need to change the code. If you're writing a new application, you're in a luxury situation because you can write the code against Spanner right away, as long as you're obviously comfortable with using Google as your only database provider in this case. It's OLTP, it's not OLAP, so you do transaction processing here, you do the real-time data of your application. If you will want to do analytics, it would be better to stream the data from Spanner into BigQuery, for example, using Dataflow, but that's a separate discussion. And if you don't really need transactions, or if you don't really need relational, or if you want to do mobile-first kind of development, another thing to take a look at is Cloud Firestore. So it's a new service which is right now being introduced on top of Google Cloud. It uses Spanner underneath as the storage layer. It also provides multi-regional, but it's more similar to data store, so to NoSQL kind of database like MongoDB. On top of that, since it's integrated with Firebase, you get thick SDKs which you can use for offloading more of the logic and more of the database management code into the actual mobile application. What's next? So if you want to learn more, if you want to try more, so I know that many people start learning Spanner from actually reading white papers. Good for them. So best practices documentation in Google Cloud is quite extensive. It guides you through the design of the primary key, it guides you through design of the schema, it guides you through the migration if you're moving out from MySQL or something like that. And I also recommend Cloud Spanner 201 session, so you can find it on Google Cloud. It's out of Google Next from San Francisco from February this year, where the product management team from Cloud Spanner actually goes deeper into execution plans and how Spanner does what it does further on. Yeah, and also around the best practices, there are tutorials on Google Cloud where you can just pick your favorite language and go through the whole process of creating a bunch of transactions and starting using Spanner with your application. That's all I have. Thank you.